Welcome back from an ad break. So before the ad break, we were looking at the chemical equations, what is entailed in the chemical equations. And then as promised, we need to know how to balance the very same chemical equations. But before we balance the chemical equations, we need to know the rules that govern the balancing of equations. So let's start. Now, we know that compounds, they have fixed ratio. They have a fixed ratio of atoms which cannot change. We know that H2O always has the ratio of 2:1. That for every 2 hydrogen atoms, there must be 1 oxygen atom. Again, when we're talking about NaCl, the ratio is 1:1. For every 1 sodium atom, there must be 1 chlorine atom. So that ratio cannot change for compounds. For all the compounds, they have their specific ratio. For an example again here, when you're looking at carbon dioxide, the CO2, we have 1 carbon atom and 2 oxygen atoms that are chemically bonded. Again, H2O, as we have spoken about it, we have 2 hydrogen atoms and 1 oxygen atom that are chemically bonded to each other. So now, to balance the equations that you're talking about, we need to follow certain rules, as I've said. And what are those rules? Let's start. Rule number 1. So you need to write the correct formula for the reactants and the products. So when you write the correct formula of the reactants and the products, we are not balancing it yet. We're just writing out the correct information from the given question or from the periodic table. Now, as we've said, we are given this particular reaction. We are writing out the products and the reactants as they are before balancing. Remember, we are not balancing yet. Then number 2, we need to find the number of atoms for each element on the left-hand side, and we'll compare those against the number of atoms of the same elements on the right-hand side. Now, what do I mean by that? So we have written out our chemical equation, It's not balanced yet. We were just writing out the information given to us. Then what do we need to do? We need to check how many of the atoms we have on the left-hand side, compare that with the number of atoms that we have on the right-hand side. On the left-hand side, on our reactants, we have 1 magnesium because there's only just the 1. We have 1 magnesium. On the right-hand side, we also have 1 magnesium, right? So the magnesiums, they are balanced, they are fine. Now looking at the oxygen on the left-hand side, we have 2 of them, but on the right-hand side, it's only just the 1. Now that's where the problem is. The oxygen is not balanced. So we need to balance the oxygen, and by balancing the oxygen, we're essentially balancing the entire equation. So as we can see, since the oxygen atoms are not equal or they are not balanced, we are going to start there. So that is our starting point, balancing the oxygen. Now, we need to determine where to place the coefficients in front of the formula. So we need to check where are we going to balance. And remember, we're balancing with the coefficients, and we know that the coefficients, they go in front of the chemical formula. So that we are using those numbers so that the left-hand side can be the same as the right-hand side in terms of the number of atoms, the number of molecules on either side. We had our chemical equation before we wrote the 2. We had our chemical equation whereby we said we have 1 magnesium, 2 oxygen, and 1 oxygen on the other side. So when we insert or when we're adding a 2 here, this 2 is going to be multiplied throughout here. So that means we are going to have 2 magnesiums and also have 2 oxygen. So now that we have that, you're noticing that we are creating another problem. So by putting in the 2 there, we are solving the problem of oxygen, but we're creating a problem in magnesium because now the oxygens are going to be balanced. But the magnesiums, they are now going to be imbalanced because on the right-hand side, we will now have 2. But on the left-hand side, we will now have 1. So we now need to then go back and balance the magnesium. So how do you go back? You check what number can you add in front of whichever one of these chemical formulas so that you can balance everything that you have there. We have balanced the oxygen, now we need to balance our magnesium. So balancing our magnesium then means we need to insert or add a 2 in front of the magnesium. And in doing so, that means on the left-hand side, we no longer have 1 magnesium, but we have 2 magnesiums. Remember, we added the 2 on the products, and this 2 is multiplying everything in this chemical formula, meaning that we have 2 Mg, we also have 2 oxygen. So now that we have 2 magnesium, the magnesiums, they are balanced. Oxygen, there's 2 of them, and this 2 times the 1 gives us the 2, so we have 2 oxygen on either side. So by doing that, we can safely say that our equation is now finally balanced. So what do? We balance by using the coefficients, and you need to check where to put in those coefficients so that the chemical formulas on either side, they are balanced. Remember, the important thing to note here is that when you are balancing, we are not adding the coefficients in between the chemical formula. Like in the case of MgO, we are not going to add the coefficient in between Mg and then say 2O, adding in our 2 in between this chemical compound. Our coefficients are written before the chemical equation. They are written before the chemical equation. That's very important to note. Then what you also need to check lastly is that the number of atoms on both sides, they must be equal. So you need to check how many we have on the left-hand side versus the number on the right-hand side. If they are equal, then the equation, we can say it is balanced. Then the coefficients are in the lowest whole number ratio. We need to make sure that our coefficients are always in the lowest possible whole number ratio. By that, what do they mean? Sometimes one of you might want to balance with a 4 here, a 2 there, and another 4 there. Now, that equation will still be balanced because we will have 4 magnesium, 2 times 2 will be 4 oxygen, and remember the 4 will multiply the 1 to have 4 oxygen. So the equation will still be balanced, but the numbers that we used to balance the equations were not the lowest one. So we can still find a common factor amongst those 3 numbers, which is a 2. So by using a 2 throughout, we are ensuring that we are balancing with the lowest whole or the lowest possible whole number. So now, when we're moving on to actually apply the rules that you have just learned into actually balancing the equations, let's see how that is going to play out. The important thing that you also need to know is that we need to count the number of atoms on the left-hand side and the right-hand side so that we can check if whether the equation is balanced and if it's not balanced. And we know that if it's not balanced, we apply the rules, check the coefficients, which ones to add and where to add, and then count again. So the counting is very important. Now, when we are counting the atoms, what do? When we are given such a chemical equation, when we are counting the atoms, we multiply the coefficient. Remember, the coefficient is the number written in front of the chemical symbol. We multiply the coefficients by the subscript of each element. So we are given 2Cr, Cl3. From here, we know that we have 2Cr, and then we are going to multiply the 2 with the 3. So we first start by multiplying the 2 with the 1, and then we get the 2. That means we have 2Cr. Then for the Cl, we multiply the 2 with the 3. So that means you're going to have 6Cl. So that's what we have. That's what I mean by counting of atoms. Then again, if we have brackets, if in brackets, the subscripts after the bracket is multiplied to the portion of everything inside the bracket. What do I mean by that? We are given this particular chemical formula with a bracket. We are saying that the subscript that is outside and outside the bracket multiplies everything inside the bracket. So the Pa will remain as 1, but then the O will be multiplied by the 2. So it's going to be 2 oxygen. And then the H is still multiplied by the 2 because it's still inside the bracket. So it's going to be 2 hydrogen. So that's what I mean by counting. We need to make sure that when we have such a thing in our chemical equation, we count the number of atoms before the arrow and after the arrow. Count on the reactants, also count on the products. So this is then now what we need to do. In chemical reactions, matter is neither created nor destroyed. It is only rearranged from one form to another. So what that means is that when we're starting with 5 substances on the left-hand side, or the reactants, even on the products, the number of atoms on either side must be equal. That's why we are balancing this equation, so that we do not destroy or create new atoms. You can't start a compound with H2 plus O2, but then your products being a NaCl. The product must correspond with the reactants that we have. Even though the properties are going to be different, but then the atoms that are making up that particular compound must still be there even at the beginning of the reaction. So in other words, the number and the type, very important, the number and the type of atoms going into a chemical reaction must be the same as the number and the type of atoms coming out of the reaction. Like I said, we can't start with H2 together with O2, but end up with NaCl. Now it doesn't make sense. Now, if an equation obeys the law of conservation, then it is balanced. So if this is obeyed, if we start with a certain type and number and end with a certain type, with the very same type and the very same number, then we can say that the equation is balanced. When we are given such a thing, we are seeing that we have 2C, we have 2O2, we have 2CO2. We said that the coefficient, the 2, only multiplies this number if there's no other atom bonded to that C. However, when you're given this, the 2 multiplies the coefficient. So that means we have 2 carbon on the left-hand side, we have 4 oxygen on the left-hand side. But on the right-hand side, we still have 2 because you're multiplying the 2 with the 1. We still have 2 carbons, and 2 times 2 is 4. We still have 4 oxygens. And as you can see, the number of carbons on either side is the same, and the type is still the same. It's carbon versus carbon, oxygen versus oxygen. Because that is maintained, the type is maintained, the number is maintained, we can say that this equation is balanced, right? However, when balancing equations, we can change the coefficient, but we never touch the subscript. We can change the coefficient, but we never touch the subscript, because the subscript determines the fixed ratio of a particular compound. Once we change the subscript, we are changing the entire compound, which now goes back to say that now the type is no longer going to be maintained. Now, this is just to reiterate that when we are balancing, the numbers at the bottom, they are off limits. We do not touch them, but we can touch the numbers in front of a chemical compound. In a case like this, the 2 here and the 2 there, we can change them. And these 2 again, we can change them, but never the ones at the bottom, the subscript, when we are balancing our chemical equation. Now, we can balance a chemical equation in many ways, by either drawing the diagrams to show that we have the same number of atoms on either side. Let's see. We are given this unbalanced equation, so we need to balance it. We have CH4, we have O2, which is going to react to form CO2 and H2. If you were to check, we have a carbon initially, still have a carbon at the end, hydrogen there, oxygen, oxygen. There is nothing new that comes out at the side of the products. And also, we don't have something on the side of the reactants that we do not have on the products. So the type is maintained. What about now the number? Let's check the number. On the reactants, we have 1 carbon, which is denoted by that yellow circle there. We have 4 hydrogens that are chemically bonded to the carbon. So we have 1, 2, 3, 4. We also have 2 oxygen atoms that are chemically bonded to form 1 molecule of oxygen. That's on the left-hand side, the reactant side. Then on the product side, we have 1 carbon, yes, so the carbons are balanced. Hydrogens, well, how many do we have? We have 2 hydrogens, 1, 2. So the 2 and the 4, so the number is not balanced. And then lastly, we have 3 oxygen atoms, 1, 2, 3. So the type is maintained, but the number is not maintained. The number is different. We need to balance the chemical equation. Remember, to balance, we use the coefficients and never the subscripts. So let's see how do we then balance. So if I insert a 2 here, these 2, remember, will multiply this, which means I will have 4 oxygens on the left. Then on the other side, I still have my 2 oxygens, And then these two will multiply the 1 here. So again, on this side, I will have 2 oxygens. So these 2 oxygens plus these 2 oxygens gives me 4 oxygens. So as we can see on both sides, the number of oxygens are balanced. Going back to the carbon, there's still 1 carbon, 1 carbon. Carbon is still balanced. And our oxygen is also balanced. Now the last thing to check is our hydrogen. So we have the 4 hydrogens on the left-hand side. Then what about the right-hand side? Remember the 2, if it's in front of a chemical symbol, it multiplies the subscript. So 2 multiplied by 2 is 4. So on the right-hand side, I have 4 hydrogens. On the left-hand side, I have 4 hydrogens. Now I see 1 carbon left, 1 carbon right. 4 hydrogens left, 4 hydrogens right. 4 oxygen left, 4 oxygens left. So therefore, the type and the number is maintained. Then we can finally say that our equation is balanced. So in balancing the equations as to recap quickly, we use the coefficients, we never touch the subscripts. The coefficients are determining the number of molecules that we find in a particular compound. Whereas the subscripts, they tell us the number of atoms that we find in a particular compound. In a case of, let's use this water again as our example. We have 2 molecules of water, and within that, within 1 molecule of water, we have 2 hydrogen atoms and 1 oxygen atom. That is very, very, very much important to know. I hope by going through all of this, you can at least start to balance equations of your own, and you now know how to balance the equations. There are certain rules that you need to follow. Do not skip any rule. Follow them from the first one all the way to the last one. Important to remember, the subscripts, we do not change. Now, with that said, learners, until next time, bye.